Use the pipette to transfer solution into the cuvette, being careful not to transfer extra solution. Repeat this process for the additional dilutions. Make sure to prepare a cuvette that will be used to zero the spectrophotometer. This is the blank solution. When using a spectrophotometer, you should scan across all wavelengths. You should do this to help determine the identity of a solution by comparing its absorbance spectrum with that of a known absorbance spectrum. You should also scan across all wavelengths to determine the point of maximum absorbance known as the lambda max. Next, you will use the spectrophotometer to measure the absorbance values of your dilutions. In this case, the spectrophotometer should be used for the scans at 560 nanometers. Do not forget to zero the spectrophotometer using your blank solution. Failing to zero the spectrophotometer would affect the measured absorbance values. Absorbance is measured as the difference in the amount of light emitted by the light bulb and detected by the spectrophotometer. The blank will allow the spectrophotometer to calibrate and account for any differences in the amount of light emitted and detected that is not a result of the absorbance of the solution. You should always wipe two sides of the cuvette, and you should place the cuvette in the spectrophotometer with those clean sides facing the beam. Also, do not forget to close the spectrophotometer before scanning. Click the button that says Scan to measure the absorbance of your sample. Make sure you record this absorbance value in your notebook to the correct number of decimal places so that you do not forget the value. Also, when you remove the cuvette from the spectrophotometer, always close the lid. The Beer-Lambert law can also be used when calculating absorbance. It states that A equals epsilon LC. A is absorbance, which doesn't have any units. Epsilon is the molar absorption coefficient, which is measured in 1/, molarity times centimeters. L is the path length, measured in centimeters. In our case, L is always 1, and C is the concentration, which is measured in molarity. Absorbance can be measured using the spectrophotometer. Epsilon can be determined as the slope of the calibration curve between absorbance and concentration, and L is always equal to 1. As long as you have the measured absorbance value or have calculated the concentration, epsilon can be calculated. Or, as long as you have epsilon and absorbance, concentration can be calculated using the Beer-Lambert's law. In other words, as long as you have 3 of the 4 variables, the other variable can be solved for using the Beer-Lambert's law. It should also be remembered that absorbance and concentration have a direct relationship. As concentration increases, so does absorbance. When you are finished reading, you can close out the program. When you are done measuring and recording all of the absorbance values, do not forget to clean your area. Always record the data in your notebook using the correct number of significant figures.